next speaker. Next presentation is going to be by the host organization, Pawsey. So we're actually going to split it up between two speakers, two smaller talks. The first speaker is going to be Ashley Chu from our supercomputing team. He's a system administrator, originally from the University of Western Australia. He's about 8 years experience in system administration. And then he moved over to IVEC, which then later became Pawsey. He currently runs one of our supercomputing platforms known as Zeus. It's a heterogeneous platform. Today he's going to be talking about our use and some best practices with the XALT and Lmod packages. And shortly after him, Mohsen Sheikh is also from the supercomputing team. He's one of our applications specialists. He's going to be talking about XDMod and the refrain test framework that's being developed at the Swiss National Supercomputing Center. We've adapted it here for essential testing on our platforms. So, Ashley, when you're ready.
I'm just seeing if it works. G'day guys. Apparently this is going to be a very tight time frame, so I'm going to go through this really quick. Basically, I'll be talking about basically XALT and Lmod. So basically, what does XALT and Lmod give you? It gives you the ability to collect cluster information for your users. So this also means information that's run by your scheduler, but also information about your users in terms of their software and use of modules and libraries. Okay? So this talk could be two parts. Lmod first and then XALT. So what is Lmod? So most of you guys who's been in the HPC space would come across using the modules environment, which is based on TCL. That's been introduced since the 1990s, and even to this day, the default module environment system is this. So what Lmod is basically a direct replacement of the traditional modules environment. So basically it's Lua based. It's freely available with all distributions, be it SLES, Red Hat, Enterprise, or anything. It's freely available. Lmod Gotchas. Okay, you got to be very careful when you use Lmod. Basically, it's been a constant iteration. Each year seems like a new version. So Lmod is not really usable until version 7. So if you use version 6 or earlier, basically it had a fundamental flaw. So it could not discern the minor versions of a module. So if you're using GCC 5.01 and you're using GCC 4.93, you could not tell the difference. So using it as for a module environment is kind of flawed. So if you can use Lmod, please use at least 7.4 or 7.5. Lmod was a development in 2017. It wasn't until mid-2017 it became usable. Okay. With Lmod, it uses the same syntax as the traditional module, so you don't need to learn anything. So you don't module load, module unload. Okay. But the problem is that with Lmod, it's computationally more expensive than the traditional deal. So when you load a module, right, all it does is amend paths, change library paths, stuff like that. Lmod does more than that. So what Lmod does is has a lot of extra functionalities. So why XALT needs Lmod is it relies on module weighting. So what that means is that this module has a lot of weighting. Their paths or for binaries or library paths is placed first always. So that's one thing, it's weighting. The other thing that Lmod does is that when you load a module, it doesn't just append paths. It actually has to look into the directory to see what's in there. So you can see libraries and stuff like that. So it is computationally a bit more expensive when you load a module. So when you load a module, it's advisable that you do module load A, B, C. Instead of module load A, module load B, module load C. What happens is that basically, if you just do module load A, B, C, it's one iteration because it has to iterate through the modules and do the weighting, so it can do it in one loop. If you do module A, B, module load A, module load B, that's 3 loops. So it has to go through the iteration 3 times. So that's why this is very important. You think that it may not add to the start time. It's quite amazing because if you look every time, basically, if you look at script summary, basically it's spawning a shell, and that shell, if you do that multiple times, it adds up. Switching to Lmod. Okay, so if you've got an existing cluster, most likely you'll be using the existing module environment, okay? You can actually bootstrap the Lmod over your existing module system and you can use it straight away. So basically, if you want to do this, you just modify your startup to the relevant shell, which is in etc profile.d, then make it the last startup thing relative to the shell. So this is great for testing if you want to see what features can be added to your existing cluster. So it can be toggled on and off by using a test condition, if file here, bootstrap this as the last phase. So when I say it can use the existing module environment, because the reason why it works is that it understands the native modules, TCL modules. So you can use that and you just use it straight away. It has no problems. But if you choose to bootstrap Lmod over the existing module farm, it's a double-edged sword. Basically, you're going it through a two-step process. You're going through the existing module environment, which loads up, then it kicks Lmod, so it has to go through the same thing again. So this will work for testing, but it's highly not recommended for a production environment if you want to bootstrap it like this. Switching to Lmod, okay. If you want to natively use Lmod, it's advisable that you install the Lmod and totally replace the module, so it's a one-step process. It's advisable if you want to use Lmod. You should rewrite basically your module's environment from the TCL to the Lua base because it has a whole heap of features we can use. You can hide modules, but the one that's most important in this case is waiting, because you can explicitly add waiting to modules, so this will always sit first. So in terms of XALT, you want XALT to sit first in terms of binary paths and library paths, because it's basically a fancy wrap-up, which I'll explain later. So if you're going to rewrite it, if you're going to write your modules, the modules has to either explicitly be either Lua or TCL based. You can't have both for the same module. But as long as you have one for one or the other, it will work fine. So as I said before, Lmod is more computationally expensive in terms of loading modules than the traditional module system. So what Lmod has done, is enabled basically a caching mechanism. So what happens is that if you set your module, a module load or something, it takes forever. What it will do is it will create a caching, and it's usually in the user's home area, to speed up successive operations. This can increase speed, but basically to generate a caching module, you need to be aware of the module. So you could generate a public cache for your cluster, okay? And that will make all your modules cache that's viewable to your user, and it will speed it up. But what happens if you got a power user? You have your power users who can compile stuff, they know what they're doing. They're going to have their own modules, own libraries, and you're not going to basically comb all the file systems just to look for their modules. So that's why I said that's a double-edged sword. Lmod caching is not tiered. So therefore, if you want to generate cache, what I would advise you to do, if users, some users are going to complain if it's an extra 20 seconds or 10 seconds, they're just going to complain. So if you want to do caching, what you want to do is get the caching be generated on the user level, because he's exposed to the global module system that's made to view by a system and their own personal cache. So basically you just have a script or something which they can run to generate their own cache. The other thing to be careful is most clusters, more HPC clusters will have a common shared home area, okay? So that's mounted on multiple clusters possibly. And not all clusters are necessarily the same, okay? Because it may be your cluster is supplied by vendor to do this, but it's only supported by XYZ. In terms of let's say for a Cray system, basically it's Celeste, okay? It's Celeste, but with proprietary Cray magic sprinkled on top. And you may have another system which is, traditionally it will be either CentOS or Red Hat Enterprise, which is a different cluster. So let's say that person logs onto the Cray, and for whatever reason, it takes forever, it generates a cache. And that cache is valid for 24 hours. Then you log into the other system, which is a CentOS within 12 periods. And if you have the same modules available, which you traditionally would, like fast Fourier transform, something, right? It's just going to load a module, but it's just going to segfault when you run a Cray. So this is basically cache contamination or cache poisoning. So you want to avoid this. So you can avoid this by setting a magical variable name called Lmod system name. If you set that, that's basically set and it's tied to explicitly to a cluster. So when it looks up for a cache or something, it looks that to the cluster specific cache by Lmod system name. This is the second part of the talk. Lessons learned with XALT. So what is XALT? XALT is the part which actually collects the job clustering information from the user's run job and the jobs that they do at compilation time. So you can see what they're linked to. So what XALT is, it relies on Lmod's precedence module. So it intercepts, basically calls to your MPI wrap, your MPI spawn binary to spawn the job in the cluster, and the linker to compile jobs. Let's say for MPI start, I'm referring to srun, AP run, MPI run. So it basically intercepts that call and basically takes information what's in this and dumps it to like a JSON file. So in terms of compiling, you can intercept what libraries it's linked to or what modules it uses. It uses basically, let's say if you do GC's compile, it intercepts the LD, so you can intercept what libraries it's linked, so you can harvest all that information. So XALT is tied explicitly to Lmod, basically. Basically, it's made by the same group and is freely available. Oh, okay, I think I've covered this. Yep. So linking wrapping, so all XALT is a very, very magical wrapper. So it just wraps around the main MPI spawn binaries, and basically the main tools that links the user's compilation, so interceptor. So this should be transparent to most users, okay? It's schedule independent because, as I said, it's just a fancy MPI wrapper. So as long as you got the wrapper in place, it will run. So when I say when it captures information from the job being run or the jobs being compiled, it basically writes it to a JSON type format. So this JSON file can be basically injected into a database several ways, indirectly or directly. When I say indirectly, it basically writes a file to your home area, which you can harvest at your leisure to be injected to a database. Directly is basically you can take the information and inject it straight to the database, or it can be logged to like a syslog mechanism, and then you can harvest it and inject it into the database. For us, we've harvested the information that's collected from the scheduler and from the link information into JSON files in the user's home area. The reason for this is not all system has direct access to the outside world or access to the database. And we also found that in some cases you can get a denial of service attack basically caused by users. But when you run a job and if a user job does srun and it does MPI spawn of a job, let's say he spawns 10 and it runs 10 jobs in 1 second, and you spread that across 1,000 nodes, guess what? Basically your scheduler will die and your database will die. So that's the reason why we harvest it via file. So yeah. So basically the one main issue is that there's a wealth of information, but all that wealth of information is contained in a database. And there is no web front end currently. But there has been papers that a web front end will be, it's been demoed. I think it's been demoed and it's been talked in a white paper, but it's not freely available at the moment. But currently there's no web front end, and basically if you want information, you need to create through a database, and it can get ugly. But any information you're interested in a job, or how how the user compiled it, or who's used this library, you can get that information. So what XALT does is, basically, as I said, XALT can collect information about usage of libraries and modules. This is useful if you want to, in terms of software maintenance cycle, you want to see what your user base is up to. You want to see if who's using this, if it's a bad library, we want to talk to people. Like, there may be a bad MKL library and your performance stuff's 50%. You want to talk to users, please recompile your stuff and use the newer MKL. Now, XALT basically depends on the reverse map to correctly map modules that's being used within a cluster. So that reverse map basically maps files to a module. So the reverse map has to be cluster aware, and the map file has to be updated every time when a new piece of software is added. Again, this is a double-edged sword, because this will work in most cases with modules provided by your HP Center, but it will not work for modules that's created by users because you aren't aware of their software. So they have their own personal modules. You can't help. You can see the binary execute, but you can't see what the modules map to because it's in their own personal area. It's helpful if you have an orderly layout of your modules, so you don't have a flat layer saying module FF tab. You need to have it like cluster, compiler, version, software, and then Sandy Bridge, and then your architecture and stuff like that, because it helps you collect information to work out where in the tree of your software stack is you need to check or verify. Now, in majority of cases, it should not affect your users at all. It's transparent, but there are some programs which will not work with XALT to trap the logging. So this is particularly true with debuggers. So anything like Forge, vTune, it will not work because when you run vTune, they want to monitor the program directly. They don't want to monitor a middleman which calls it. Okay? So basically you get CSEG fault. But the easy way is just to get around that when they use debuggers, module unload XALT and then let them run debuggers. Most cases it's fine because for people to use debuggers, they know what they're doing. They're your expert users. Okay? Data finding components that may not work is MPI-based programs, but they're not spawned by MPI run or S run or app run. Basically, they have their own fancy wrap-up. So that's the only kind of thing that I found does not work. Now, the last 4 slides is just examples of the ugly SQL statement, but it shows you the power that it has in terms of information in the database. In this example, basically, I'm showing you. Basically, I want to know who's compiled stuff with link to the libMPI. As you can see, it's Brian running, basically complying a OSU benchmark. So you can see date, time, path, cluster, where it's linked. So you can find, if you're interested who's using this, you can find out libraries or modules. You can look at that. Now, the next basically is sample slide is, shows you the linked library scene. So in this case, you can see who's using which library and how many times it's been linked. So you can see how important this library in terms of your cluster relative to the others. Notice that it says module name equals null. So as I said, if the library is has no reverse mapping, you won't be able to tell to a module like LD or GNU, libgcc. That's the system GCC. So that's why I say it will never reference. But if it's mapped correctly, you can see like someone's compiled against the Intel MPI library on things. So you can verify who's using it, what's using it, stuff like that. Now you can also find out, how you want to, because modules in the system basically grows out of proportion. You want to trim and maintain stuff, so you can see how many actively how many jobs it's been using or how many service units being used in terms of that. So you can actually look at it, see if it's worth active maintaining or drop it or whatever. So yeah. So as I said, you can see it's shifter and it's part. Now refers to anything that does not refer to a module that's so it could be user's own modules in their home area, or it could be bin/shell, which is a system path binary. And I think this is just showing you can see you can say how many times has the binary been used on the system, and then you just get a whole slow list and it gives you a count. And you can see someone's been doing, Marcheck's been doing a lot of beam tests, someone's been doing query. That's basically the end of my talk because I think I'm coming past my time frame. But you can see the importance of this because hardware is only 50% of the problem. The other 50% is basically software. To get the performance, you need to see if the software is compiled correctly or it's used correctly, because you spend a lot of time maintaining software. This just gives you a reference base in terms of your user base in terms of software. Because software is without it, it just won't run. Okay, that's it. Thank you.